Okay, this is part 2 of exponent laws. We're going to do a few more exponent laws. Learn 3 more actually today. Power of a power, power of a product, power of a quotient. You're like, what? Well, let me explain, okay? Let's just do a quick review of the exponent laws you know so far. And I think those would be these ones here. The product, remember multiplication? Whoops, what happened there? Remember multiplication? Bases are the same, we add the exponents, right? How about the quotient? Yes, when the bases are the same, we subtract the exponents. And just as a quick review of the exponent law of 0, anything to the power of 0 is just equal to 1. So now what I'm going to ask you is let's look at what a power to a power looks like. And here are some examples here. So here's my power, 3 squared, raised to the power 4. As repeated multiplication, remember this is 3 squared, and the power of 4 means I'm multiplying this 4 times, or there are 4 factors of the same thing. So this is now just 3 squared times 3 squared times 3 squared times 3 squared. Multiplying with the same base means you just add the exponents, so that's just 3 to the power of 2 plus 2 plus 2 plus 2, or 3 to the power of 8. Okay? Now, in class, I did the variables, so hopefully this is nothing new, but m just represents a number, so we can just write this as m squared, and because this is raised to the power 3, there are now 3 factors of m squared, and that's just m with a 2 plus 2 plus 2, or just m to the power of 6. So, once again, comparing exponents to the answer, what do you see here? So to raise a power to a power, the key thing now is to, multiply the exponents. So the exponent law for a power to a power is this. If we have a to the power m, all raised to the power n, we just keep the base the same as a, and we multiply the two exponents m times n. Okay? Now, what if the number in the bracket is more complicated? So now I've got not just a number, but I'm multiplying it by something else, like a letter. So once again, we can do the same thing. 5n squared cubed just means 5n squared multiplied by itself 3 times. Now here, I'd like you to regroup the repeated multiplication. I'm going to group the numbers together. So 5 times 5 times 5. I'm going to group the n's together. N squared, n squared, n squared. And as a single power, notice we have 5 to the power of 3, and we have n to the power of 2 plus 2 plus 2 is 6. Or if you like just writing numbers, 5 cubed is 125, n to the power of 6. Okay? Do the same thing for the next one now. So negative x squared y, not once, not twice, not 3 times, but 4. Now let's do the regrouped repeated multiplication. I see negatives, and I see a negative 1. Let's see, I see 4 of them. Okay. X squared, I see 4 of them, I think. And I see a y, and there's 4 of them. So negative 1 to the power of 4. Okay, there's my number. X 2, 2, 2, 2 is 8. Y is 4. And if you want to simplify this, negative 1 to the power of 4 is just positive 1, so x to the power of 8, y to the power of 4. So this is called the distributed or applied thing, where now notice the exponent gets distributed to both, because you'll see, hey look, the 5 gets raised to the power of 3, so here we go, right? 5 gets raised to the power of 3, and also the n squared gets raised to the power of 3, that's n to the 6, and so on. So that's why we call this the distributed part. We're going to distribute the exponent now to each of the bases inside the bracket. Okay? So this is called the exponent law for a power of a product, because inside the bracket you have a product of 2 things or more, and you're distributing the exponent into both of those things. Okay. Alright, so let's take a look at the next page and try these now. Write using only one exponent. So notice this is a power to a power, so this is just 6 to the power of 21. Okay. Notice in this case, be careful, that negative actually is like another number, so we're going to have to actually apply and distribute it. So this is what we call a power of a product. Notice the negative gets distributed with the power of 5, and also the 2 cubed now gets raised to the power of 5. So negative 1 to the power of 5, of course, is just negative 1. 2 cubed is just the same thing as 2 to the power of 15. So if you want to write this as negative 2 to the power of 15 like this, that's perfectly fine. Okay. Part C, once again, wow, lots of stuff here. So we're going to distribute once again to every single term. And then say to yourself, negative 3 squared, that's 9. X squared squared, that means you multiply it, power of 4. Y to the power of 4 squared, that's y4, that's 4 plus 4, which is 8. There you have it. Okay. And then do the same thing with part D. I know it looks scary, but nonetheless, same ideas. The m squared gets applied to the power of 3. The n gets applied to the power of 3. And then over here, we're going to do the same thing. So the m cubed gets applied to the power of 2, and the n gets applied to the power of 2. Simplify. M squared cubed. Once again, this is now a power of a power. So that's m to the 6, n cubed. This one also here is m to the 6, n squared. Now we can leave it like this, but I'd like you to simplify by writing it as one single power if possible. So notice here we've got m power 6, m power 6. We can combine them together. This is multiplication. So now we have to do what with the exponents? 6 plus 6. Very good. Add them. Similarly with the n cubed and n squared, this is multiplication. 3 plus 2 then is just 5. Cool. Now just like how there is an exponent law for a product of a power of a product, sorry, there is a similar law for a power of a quotient. And can you guess what that happens, or what happens here? Yeah, you'll just distribute the exponent into both the top, or the numerator, and the denominator. So, applying this fact now, let's see if you can do example number 2. 5/6 all to the power of 3. That means I just distribute the 3 to the numerator and the denominator. And that's it. If I ask you to find the number, now we can go 5 cubed, that's 125. 6 cubed, that's 216. And there's your fraction, 125 over 216. Do the same thing with the next one, please. So we're going to apply the x squared, apply the power 4 to the x squared. Apply the power 4 to the y cubed separately, like this. Then use power to a power, x squared to the power 4. Multiply. And then the bottom, if you said multiply, you're also right. There you go. That's it. Last one. Once again, let's apply that power of a quotient property. 5m squared cubed, 2n cubed cubed. And then now we have to apply the distributive property. So we have to now distribute. So this is the power of a product. That's 5 cubed. And then also m squared cubed. Same thing at the bottom. 2 cubed. N cubed cubed. And then now we can simplify 5 cubed. That's 125. Here's a power to a power. M to the power of 2. All cubed. 2 times 3. That's 6. So m to the power of 6. On the denominator, 2 cubed is just 8. N cubed cubed, 3 times 3, that's n to the power 9. And that is your final answer. Okay, last one. I'd like you to try to simplify this. Notice we got this division, all raised to the power of 3. I'd like you to do this actually 2 ways. And I've actually shown you or told you what the 2 ways are, but I'd like you to see if you can do it yourself. So the first way, distribute the power first, like what we did in example number 2. Okay? And the second way, use order of operations and say, let's simplify the brackets first. Let's see if you get the same answer both ways. You try this on your own. Pause the video, try it on your own, come back and take a look if you're right. First way, distribute the power first. So 12a squared b4 cubed all over 4ab squared cubed. Which means we cube every single thing inside. Cubed. Cubed. Same with the denominator. Cubed. A cubed. Cubed. Then we'll ask you to evaluate. So 12, well, that's 12 times 12 times 12, 1,728. Multiply the exponents, because of the power to the power. Multiply the exponents, power to the power. 4 cubed, that's 64. This is a, remember, power of 1, so 1 times 3 is just 3. A cubed. B squared cubed. Power to the power, that's 6. And now we have to simplify. We can divide the numbers, so 1,728 divided by 64. 1,728 divided by 64. That's 27. We can now divide this part, a6, a cubed. Dividing, base is the same, so we subtract the exponent. A cubed. Same thing here with the b's. Exponent is the same, we subtract the exponents. That's my final answer. Okay. That's called distributing power using the distributive law, or the power of a product law first, or the quotient law. We can also do it the second way, called simplifying the brackets first. So let me just copy down the question again. And this is like doing order operations, so I will do the brackets first. And if we did that, let's see what happens. I'm going to ask you to divide 12 divided by 4. Yeah, that's easy. How about the a squared and a? Remember that a by itself is just the power of 1, so 2 minus 1 is just 1. Put the 1 there to 1, which is 2 off, doesn't matter. And then b to the power of 4 divided by b squared, 4 minus 2 is 2. So I could simplify it first like this, and then now I'll be ready to apply the exponent law for the power of a product. And that means, of course, I now need to distribute the 3 into all of my terms. So this becomes 3 cubed, a becomes a cubed, and the b squared becomes b squared cubed. And 3 cubed is 27. A to the power of 3 is just a to the power of 3. And b squared cubed is just b to the power of 6. Whoa, it's the same. So, which way do you like better? It's really up to you. Tell me what you prefer when you come back to class. That's it for this video.